Okay, now let us go with the eighth problem. Right, let me start the timer. Right. Two blocks of different masses are released from different identical springs of elastic constant K. Same spring, different masses. Okay. So you have one mass like this and initially compress a distance of delta x, blocks x as a mass of 1 kg and 0.25 kg. What are the velocities? So initially what I will do is I will consider one block like this, the other block like this. And one has a mass of 1 kg, other has a mass of 0.25 kg. Now what you do is you actually compress this one here or mass release from identical springs. So you compress it and then leave it. So as a result of it, one block will move faster, the other block will move with a different speed. This moves, let us say V1, this moves at the speed of V2. Now he is asking you what are the velocities of blocks X and blocks Y. Okay, fine. So towards it, how do we do this? We do it like this. So why should the block move with different velocities? Who gets the energy? How does it get the energy? It gets the energy because of the energy stored in the springs over here. What is the energy stored in the spring? The energy stored in the spring, we already lost 1 minute. Okay, anyway. So energy stored in the spring is nothing but half k x square. This should now be equal to half mv square, right? So now what does it say? The spring was compressed by delta x equal to 0.1 and k value is also given. So this half and this half goes away. So what we will do is we want V1 and V2 here separately. So we will substitute the values. What is k here? K is 100 multiplied by x value is 0.1 square. Should now be equal to how much is it? So this should be equal to 100 multiplied by 0.01 which is equal to 1. Okay, and this is not changing for both the calculations. So I will just write. So half mv1 square. So mv1 square. mv1 square, m1 v1 square is equal to 1 for the first one. What is the mass of the first one? 1 kg object. So I will substitute here. You get m1 equal to 1. So v1 square equal to 1. v1 equal to 1 meter per second. Which one is correct? These two are correct. These two are incorrect. Eliminate this. Then v2. Now what will happen to v2? m1. What is m2 here? m2 is 0.25 which should be 1 by 4th of a kg into v2 square equal to 1. This implies v2 square should be equal to 4. v2 should be equal to 2 meter per second. So therefore which is the right answer? So this should be the right answer, right? So this is incorrect. And thus you can see C is the right option. The other way of looking at this problem is that since for V1 is equal to 1 meter per second for M1 equal to 1 meter. So here you can see this cannot have the same velocity, right? So therefore directly this could be the right answer, so that you can eliminate this option also. Instead of doing the calculation, you can do it like this also. To confirm whether your reading is correct or not, you can do this. But if you have a very shorter time, unit of time, then you can go by this method also. Okay, let us move on for the ninth